Today we're going to solve equations. To solve an equation means to find the value of the unknown. In other words, you have to determine what the variable is equal to. And the way that you find the value of the unknown is you isolate the variable. It means to get the variable on one side of the equation by itself. In order to isolate the variable on one side of the equation, you have to undo what's being done to the variable. In other words, you have to use the inverse operation. So we're going to use addition to undo subtraction. We're going to use subtraction to undo addition. We're going to use division to undo multiplication. And we're going to use multiplication to undo division. The cardinal rule in solving equations, as we have observed in the slides previously, is that what you do to one side of the equation, you must do to the other. Remember the balance scale analogy that we discovered on one of the slides. In general, most of the time, you undo addition or subtraction before undoing multiplication and division. If you'll recall, when we were discussing the order of operations, you simplified what was in grouping symbols first. Then you simplified any exponential powers. Then you performed the multiplication and division in the order it appeared from left to right. And the last thing you did was perform the addition and subtraction in the order it appeared from left to right. Well, when we solve equations, that which we did last, we undo first. So the last step in reference to the order of operations was to perform the addition and subtraction in order it appeared from left to right. So when we solve an equation, that which we did last, we generally undo first. So the first thing we're going to undo when solving an equation is the addition and or subtraction. Most of the time. There are some exceptions, but in general, we're going to undo the addition and subtraction before undoing any multiplication and or division. So let's look at our first example. We're going to start out with some very simple ones, and these you can probably just look at and determine the answer. But as the equations become more complex, then it's essential for you to follow the rules that I've outlined here on the left. So when solving an equation, ask yourself two questions. One, what is the variable? And of course the variable here is x. So we want to get x by itself on one side of the equation. So we want to go from this equation, x minus 2 is equal to 8, to x is equal to something. Now, in order to do that, the second question you must ask yourself is, what is being done to your variable? Here, 2 is being subtracted from x. So, to undo subtraction, we're going to use addition. So I've got to add 2 to the left side of the equation. But what I do to one side of the equation, I must do to the other. So I must also add 2 to the right side of the equation. Now, it's very important that you keep up with these signs, because it's going to tell you over here on the right side whether you need to add or subtract. If you have like signs, and here we do have like signs because this is understood to be a positive 8, you're going to add. If you have unlike signs, then you're going to subtract. So 8 plus 2 gives us 10. Now here on the left side, the minus 2 and the plus 2, they do each other in, and that gives you x is equal to 10. So we transform this equation using these particular rules from x minus 2 equal to 8 to simply isolating the x on the left side of the equation, and we got x is equal to 10. Now, you should always check your solution to see if that is indeed what the variable is equal to. Now in this case, I believe that x is equal to 10. When I solve this equation, that's what I got. So go back to the original equation. X minus 2 is equal to 8. And now we're going to substitute 10 in for x, just like we did when we were evaluating algebraic expressions. And if I solve this correctly, then the left side should equal the right side. 10 minus 2 is 8, and 8 is equal to 8. Checks out. Again, I will solve this equation. So I ask myself two questions. One, what is the variable? The variable here is n. The second question I ask myself is what is being done to the variable? 8 is being added to n. Now to undo what's being done, I must use the inverse operation. The inverse of addition is subtraction. So we use subtraction to undo addition. So I must subtract 8 from the left side. But what I do to one side of the equation, I must do to the other. So here the plus 8 and the minus 8, they do each other in, and that's what you want to happen because you want to isolate the variable. Get the variable by itself. So here I have the variable by itself. Now on the right side, notice that I have unlike signs. You have unlike signs, you subtract their absolute values and attach the sign of the one with the greatest absolute value. So n would be equal to -6. And again, you should check your solution in the original equation. N plus 8 is equal to 2. I believe that n is equal to -6. So I substitute -6 in for n. So I have -6 plus 8 is equal to 2. If I did this correctly, when I simplify, the left side should be equal to the right side. -6 plus +8 is +2, and 2 is equal to 2. Checks out. Again, we're looking at very simple equations in which we're solving for the unknown. In this particular case, I have 2x is equal to -8. Remember, 2x means 2 times x. So again, the two questions you ask yourself, number one, is what is the variable? My variable is x. And you ask yourself, what is being done to x? X is being multiplied by 2. Now, when I say solve for the unknown, in this particular case, I want x. That's understood to be +1 times x. Because 1 times anything is anything. 1 times x is x. So I do not want 2x. I don't want the opposite of x. I don't want 4x. I want x, or +1 times x. So once you identify the variable, ask yourself what's being done to the variable. In this case, x is being multiplied by 2. So in order to isolate the variable on one side of the equation, I need to undo what's being done. Well, x is being multiplied by 2. So we use division to undo multiplication. So I'll have to divide both sides by 2. And this is the way that I indicate that I'm dividing by 2. Remember when we were discussing fractions? The fractional bar is nothing more than a division symbol. Now 2 divided by 2 is equal to 1. 1 times x is x. And -8 divided by +2, and dividing two numbers with unlike signs, so the quotient is going to be negative. So x is equal to -4. Again, you should check the solution. So that's 2 times x is equal to -8. I believe x is equal to -4. So I'm going to substitute -4 in for x. Now if I did this correctly, when I evaluate, the left side should equal the right side. 2 times -4 is -8, and -8 is equal to -8. Checks out. Here we have another equation we want to solve for the unknown. Again, the two questions that you ask yourself, what is your variable? In this case, my variable again is x. And what is being done to your variable? Here, x is being divided by 4. That's what the fractional bar indicates. Now remember, I don't want 1/4 x, or the opposite of x, or 2x. I want +1 times x, or simply x. So the second question you ask yourself is what is being done to your variable? Well, your variable is being divided by 4. So we use multiplication to undo division. So I've got to multiply the left side by 4, or 4 over 1 if you like. But what you do to one side of the equation, you must do to the other. So I must multiply the other side of the equation by 4 over 1. Now what's going to happen here on the left side, or the 4's are going to cancel out, and that gives you x divided by 1. And over here we have negative 4, or negative 3 times 4, which is negative 12 over 1. Of course, anything divided by 1 is itself, so that x is equal to negative 12. Now, if I did this correctly, let's check it out. If I substitute negative 12 in for x, the left side should be equal to the right side. So I have negative 12 over 4 should equal negative 3. Well, negative 12 divided by positive 4, negative divided by positive is a negative. Negative 12 divided by positive 4 is negative 3. So the left side is equal to the right side. The equations in the previous examples that we have solved have only involved one step. The equations that we're going to solve in the next couple of frames are going to involve more than one step. However, you start out the same way. You ask yourself, what is your variable? The variable here is x. You ask yourself, what is being done to your variable? Well, your variable is being multiplied by 3, and from that product, 5 is being subtracted. So we have two operations involved here. Your variable is being multiplied by 3, and from that product, 5 is being subtracted. Now, in general, we undo the addition and subtraction before we undo any multiplication or division. So I need to undo the subtraction of 5. So we use addition to undo subtraction. So I need to add 5 to both sides of the equation. And don't forget these signs, it's very important. The minus 5 and the plus 5, they do each other in. And that leaves me with 3x is equal to, here we have like signs, you have like signs, you add, is equal to 12. I have simplified the equation somewhat, but I'm not where I need to be. Because in order to solve an equation, it means to isolate the variable on one side of the equation. Well, I have 3x. I don't want 3x or 2x or the opposite of x or 1/4 x. I want positive 1 times x. So now I'm going to solve this particular equation. 3x is equal to 12. So x is being multiplied by 3. We use division to undo multiplication. So I'm going to divide both sides of this equation by 3. Here, 3 divided by 3 is 1. So that gives me 1 times x, or simply x, is equal to 4. And again, you should always check your solution in the original equation. If I solve this equation correctly, when I plug 4 in for x and simplify, the left side should be equal to the right side. So I have 3 times 4 minus 5 is equal to 7. 3 times 4 is 12, minus 5 should be equal to 7. 12 minus 5 is 7, and 7 is equal to 7. Checks out. We're looking at solving equations that are becoming increasingly a little more complex. So here we have 6x minus 4x plus 12 is equal to 64 minus 20. Now, before I go adding or subtracting or multiplying or dividing both sides of the equation by some number, I need to write the equation in its simplest possible form. Write the equation in its simplest possible form. What I mean by that is to combine like terms that are on the same side of the equation. So we're going to combine like terms on the same side of the equation. So on the left side here, I have 6x minus 4x. On the right side, I have 64 minus 20. These creatures are like. These creatures are like. So 6x minus 4x simplifies into 2x. So I have 2x plus 12 is equal to, and 64 minus 20 simply gives me 44. So it's much easier to work with the equation 2x plus 12 is equal to 44 as opposed to 6x minus 4x plus 12 is equal to 64 minus 20. Now it becomes an equation like we have previously solved. You ask yourself, what is your variable? Your variable is x. What's being done to your variable? X is being multiplied by 2, and to that product, 12 is being added. So we basically here, in order to isolate the x, remember what we want to do is we want to isolate the x on one side of the equation. So in order to go from here to here, I've got to get rid of this factor of 2 and also the plus 12. In order to go from here to here, which means that we want to isolate the variable on one side of the equation, I need to get rid of this factor of 2 and this plus 12. Now, in general, we undo the addition and or subtraction before we undo any multiplication or division. So to undo the addition of 12, we use subtraction to undo addition. So I'm going to subtract 12 from both sides. Here the plus 12 and the minus 12 will do each other in, and that will give me 2x. And here I have unlike signs, so I'm going to subtract. Subtract the 12 from the 44, which gives me 32, positive. And I'm not quite where I want to be. Remember, I don't want 2x, 3x, 4x, or the opposite of x. I want x. So again, ask yourself what's being done to your variable. Your variable is being multiplied by 2. To undo multiplication, we use division. So I'm going to divide both sides of the equation by 2. 2 divided by 2 is 1. 1 times x is x. Or positive 1 times x. That's what I want. I want the coefficient for x to be positive 1. Not minus 1, but positive 1. 32 divided by 2 is 16. So x is equal to 16. Now I should check this. So I could check it in the equation at the top, 6x minus 4x plus 12 equals 64 minus 20. But I'm fairly confident that that is equivalent to 2x plus 12. So I'm going to just substitute 16 in for x in this equation. And if I did this correctly, when I simplify, the left side should be equal to the right side. So 2 times 16 is 32. So that's 32 plus 12 should be equal to 44. 32 and 12 is 44. Left side's equal to the right side. So I have solved that correctly. Again, the equations are becoming a little bit more complex here. As we've learned in the previous example, before I start adding or subtracting or multiplying or dividing both sides of the equation by some number, I want to express the equation in its simplest possible form. Now here I've got to solve for x. So I need to isolate x on one side of the equation. I need to get x by itself. So I want to go from here. I'm going to go from here to here. Now in order to go from here to here, somehow I've got to get rid of these grouping symbols. So what I'm going to have to do is distribute the 2. I'm going to have to multiply everybody inside parentheses by the 2 on the outside. So that gives me 8 plus 2 times x is 2x, and plus 2 times minus 5 is minus 10, is equal to 14. So what I did was I distributed the 2. Now, just as I did before, I'm going to combine like terms that are on the same side of the equation. So 8 subtract 10 gives me a minus 2. So this is 2x minus 2 is equal to 14. 8 and minus 10 are like terms, and they're on the same side of the equation. So combine like terms that are on the same side of the equation. Now I have the equation in its simplest possible form. So I ask myself, what's being done to my variable? My variable is being multiplied by 2, and from that product, 2 is being subtracted. So in general, I'm going to undo the addition or subtraction before I undo multiplication or division. So to undo the subtraction of 2, we use addition. Use addition to undo subtraction, because addition and subtraction are inverse operations. But remember, what you do to one side of the equation, you must do to the other. So I added 2 here, so I'm going to add 2 here. And again, it's important to put these signs, because when you combine these two constant terms, you want to know whether you're going to add or subtract. The minus 2 and the plus 2 do each other in, and that gives me 2x is equal to, here I have like signs, so I add 16. So I divide by 2, and I get x is equal to 8. Now again, you should always check that. I'm going to go back to the original equation, just in case I happen to make a mistake here. And I'm going to substitute 8 in for x. So that's 8 plus 2 times the quantity, x minus 5. But x is 8, so that's 8 minus 5 equal 14. And now I can combine these. Couldn't combine the two terms here because they're not like, but here I can combine the two terms. And that gives me 8 minus 5, which is 3. So that's 8 plus 2 times 3 is equal to 14. Now remember, when I simplify this, if I did this correctly, the left side should be equal to the right side. So that's 8 plus 6 should equal 14. 14 is equal to 14. It is solved correctly. Now this equation differs from the one that we have previously solved in that we have a variable on both sides of the equation. Before the examples that I showed you, we may have had a variable or like terms containing a variable on the same side of the equation, so we simply combine those like terms on the same side of the equation. Here, 3x and 6x are like terms, but they're on different sides of the equation. Now, when I gave you the rules for solving equations, I said to isolate the variable, meaning a variable, meaning one variable on one side of the equation. Well, here I have a variable on both sides of the equation. Well, I can't isolate a variable, one variable, on one side of the equation if I have a variable on both sides of the equation unless I eliminate one of those variables. Again, when I gave you the instructions for solving an equation, I said isolate the variable, meaning a variable, meaning one variable on one side of the equation. Well, I can't isolate a variable on one side of the equation if I have a variable on both sides of the equation unless I eliminate one of those variables. So when you have a variable on both sides of the equation, you eliminate one of those variables by adding or subtracting it out. But now remember, what you do to one side of the equation, you must do to both sides of the equation. So here I have a 3x and here I have a 6x. Now it doesn't matter whether you eliminate the 3x or the 6x. You're still going to get the same answer. Now a lot of students like for the coefficient for their unknown to remain positive. So in order for that to happen, I would have to subtract 3x from both sides of the equation. I could subtract 6x from both sides of the equation, and that would give me a minus 3x here. A lot of students don't like the coefficients for their variables to be negative, so I'm going to simply eliminate the variable on the left side of the equation by subtracting 3x from both sides. Remember, what you do to one side of the equation, you must do to the other. The 3x and the minus 3x will do each other in, and that's what I want to happen. I want the variable on one side of the equation to go away. So that leaves me simply with minus 18 is equal to 6x minus 3x. I have unlike signs, so I subtract. 3x from 6x is 3x plus 24. So I've eliminated the variable on the left side of the equation. So now I have a variable just on the right side of the equation. So that's the side of the equation that I'm going to isolate this variable. I want to go from 3x plus 24 down to simply x. So I ask myself, what is being done to my variable? My variable is being multiplied by 3, and to that product, 24 is being added. So in general, I undo the addition or subtraction before undoing any multiplication or division. But the first thing you need to do is eliminate one of those variables. If you have a variable on both sides of the equation and you want to isolate the variable, meaning a variable on one side of the equation, you must eliminate one of those variables by subtracting it out. And I've already done that. So now I'm going to subtract 24. And again, this is crucial. Keeping up with your signs, because when I combine these two constants over here, I need to know whether I'm going to add or subtract. The plus 24 and the minus 24 will do each other in, and that will give you 3x is equal to, since the signs here are alike, I add and attach the common sign. So that gives me 3x is equal to a negative 42. Now I'm going to divide both sides by 3, because remember, I don't want 3x, I don't want 2x, I don't want the opposite of x, I want x, which is positive 1 times x. So negative 42 divided by 3 is equal to negative 14. Now, if I did this correctly, if I substitute negative 14 in for x in the original equation, and I simplify, then the left side should be equal to the right side. So I think this one is definitely worth checking. So let's see, I have 3x minus 18 is equal to 6x plus 24. And I believe that x is equal to minus 14. So everywhere I see an x, I'm going to substitute in negative 14. So that's 3 times negative 14, subtract 18, should equal to 6 times a negative 14 plus 24. 3 times a negative 14 is negative 42. Subtract 18. 6 times a negative 14 is a negative 84 plus 24. And again, once I evaluate or simplify the left and right sides, the left side should be equal to the right side. So I have negative 42 subtract 18. So that's going to give me a negative 60. And minus 84 plus 24 is also a negative 60. So the less, in this particular equation, before we start adding or subtracting or multiplying or dividing both sides of the equation by some number, notice that you do have some like terms on the same side of the equation here on the left, and these two terms are like here on the right. So the first thing I'm going to do is to simplify this equation as much as I can. So 5y minus 2y is 3y plus 11 is equal to 8y plus 26. Now notice again that I have a variable on both sides of the equation. When I gave you the instructions for solving linear equations, I said isolate the variable, meaning a variable, meaning one variable on one side of the equation. Well, I can't isolate a variable, one variable on one side of the equation if I have a variable on both, unless I eliminate one of those variables. So I need to eliminate either the 8y or the 3y by subtracting or adding it out. In this case, I'm going to choose to eliminate the 8y by subtracting 8y from both sides of the equation. Remember, what you do to one side of the equation, you have to do to the other. Now, many of you probably would have subtracted 3y from both sides of the equation so that you would have a positive coefficient for your unknown, but it really doesn't matter. 3y minus 8y, since these two terms are have different signs, we're going to subtract. So that gives me minus 5y plus 11 is equal to 26. Now I have a pretty simple equation remaining, a lot simpler than what I started with. So now, in order to isolate the variable, I've got to go from this current equation that I have here to one where I have isolated the y on one side of the equation. So I need to undo the addition 11, and I also need to undo the multiplication of minus 5. Now remember, we use subtraction to undo addition, so I'm going to subtract 11 from both sides of the equation. And again, keep up with your signs here because you need to know whether you're going to add or subtract. Here, where I have my constant terms, and that's determined by whether you have like or unlike signs. So here I have unlike signs, so I'm going to subtract, so that's going to give me 15. The plus 11 and the minus 11 will do each other in, and that gives me minus 5y is equal to 15. Now keep in mind now, I don't want minus 5y, I don't want the opposite of 5y, I don't want 2y, I don't want 5y, etc. I want positive 1 times y, which is simply y. So since y is being multiplied by negative 5, we used division to undo multiplication. So I'm going to divide both sides by negative 5. Negative 5 divided by negative 5 is positive 1. Positive 1 times y is y. So it gives me y is equal to negative 3. I would not divide by positive 5 here because then that would give me the opposite of y, and I want y. If you wind up with the opposite of y, then simply multiply both sides by negative 1. Remember, what you do to one side of the equation, you have to do to the other. Now we really should check that. So I'm going to check it in this portion of the equation. I'm relatively sure that what I've done to go from step 1 to step 2 is correct. So I have 3 times negative 3 plus 11 is equal to 8 times negative 3 plus 26. Now if I did this correctly, when I evaluate the left side and the right side, or simplify the left side and the right side, the left side should be equal to the right side. So that's minus 9 plus 11 is equal to minus 24 plus 26. Minus 9 plus 11 is 2, and minus 24 plus 26 is 2. Checks out. Here we're working with a problem that the coefficient for our variable is a fraction. Well, if you don't like fractions, guess what? You really don't have to deal with them. So what I'm going to do here is I'm going to eliminate the fraction downstairs. So to eliminate the fraction downstairs, I need to multiply both sides of the equation by 4. And remember, what you do to one side of the equation, you have to do to the other. So now I distribute the 4. Multiply everybody inside by 4. So this is 4, or 4 over 1, times 3/4 y minus 4 times 14 is equal to negative 23 times 4. Now here the 4's will cancel. 4 divided by 4 is 1. 1 times anything is anything. So that's 3y over 1, which is simply 3y. So the fraction downstairs has gone away. Minus 4 times 14 is 56. And 4 times 23 is, or negative 23, is negative 92. Now we have no fractions to deal with. So I solve the way that I normally do. So I'm going to add 56 to both sides. And the minus 56 and the plus 56 will do each other in. And here I have minus 92 plus 56. So I have unlike signs, so I'm going to subtract the 56 from the 92. And minus 92 plus 56 gives me minus 36. Divide both sides by 3. And you get y is equal to negative 12. Now this one might be worth checking, since it does involve a fraction. So I have 3/4 times y minus 14 is equal to negative 23. That was our original equation. So I'm going to substitute negative 12 in for y. So that's 3/4 times negative 12 over 1. Subtract 14 should equal negative 23. Now this is not negative 12 over negative 1, because if it were negative 12 over negative 1, it would be positive 12 and not negative 12. 4 going to 4 once, 4 going to 12 3 times. So that's 3 times the negative 3, which is negative 9. Subtract 14 should be equal to negative 23. 9 subtract 14 is negative 23, and that's equal to negative 23. Again, we're looking at solving equations that are a little bit more complex. Here we have fractions. We have denominators of 5, 3, and 6. And again, if you don't like dealing with fractions, you do not have to deal with those. What you can do is eliminate the fractions by multiplying by the LCM, or what would be the lowest common denominator, of those particular fractions. So let's find the LCM of 3, 5, and 6. If you want to, you can make a list. We've done that earlier. 3, 6, 9, 12, 15, etc. 18. These are all multiples of 3. Multiples of 5 would be 5, 10, 15, 20, 25. Multiples of 6 would be 6, 12, 18, 24, 30. So I haven't really gone far enough. I'd have 30 here, and eventually I would have 30 here. So 30 is the LCM. So what I'm going to do is multiply both sides of this equation by 30. Multiply both sides of the equation by 30. Remember, what you do to one side of the equation, you have to do to the other. So the LCM is 30. So I'm going to multiply both sides of the equation by 30. The purpose for multiplying by the LCM is so that the denominators all become 1 downstairs. In other words, they go away. Now, remember you have to distribute. So I've got to multiply everybody inside grouping symbols here by 30. Now look what happens. 5 will go into 5 once, 5 will go into 30 6 times. 3 will go into itself once, 3 will go into 30 10 times. 6 will go into itself once, 6 will go into 30 5 times. So 1 times 1 is 1, my denominator becomes 1. So 6 times 6x is 36x. 1 times 1 is 1. 10 times 2 is 20. 1 times 1 is 1. 5 times 5 is 25. Now it becomes a much easier problem to solve because I don't have to deal with fractions. So I'm going to add 20 to both sides of the equation. The plus 20 and the minus 20 would each other in. This would be 45 on the right side and 36x on the left side. Now I divide both sides by 36. And that gives me x is equal to, and both of these contain a common factor of 9, so I can divide 9 out of each one of these. 45 divided by 9 is 5, and 36 divided by 9 is 4. So x is equal to 5/4. So you may say, okay, well that's really messy. How am I going to check that? Well, the same way that you have done all the other ones previously. You're going to substitute 5/4 in for x. So that becomes 6/5 times 5/4 minus 2/3 should be equal to 5/6. The 5's cancel. That gives you 6/4, which is actually 3/2, minus 2/3 should equal to 5/6. Finding a common denominator for these two terms, which would be 6. 2 will go into 6 3 times. 3 times 3 is 9. 2 will go into 6 3 times. 3 times 3 is 9. Minus. 3 will go into 6 2 times. 2 times 2 is 4. 9 minus 4 is 5. 5/6 equal 5/6. Checks out. Again, we're solving equations that involve fractions, and if you don't like fractions, you don't have to deal with them. Again, look at your two denominators and find the LCM of 2 and 5. And the LCM of 2 and 5 is 10. So what I'm going to do is multiply both sides of the equation by 10. Remember, what you do to one side of the equation, you must do to the other. 5 will go into itself once. 5 will go into 10 2 times. 2 will go into itself once. 2 will go into 10 5 times. So that becomes 5 times x minus, the quantity x minus 3 is equal to the quantity 2x plus 4 times 2. Now distribute your 5 and distribute the 2 here. That will give me 5x minus 15 is equal to 4x plus 8. Multiply each of these by 2, each of these by 5. Now I have a variable on both sides of the equation. So to solve this, what I need to do is eliminate one of these variables. So I'm going to eliminate the 4x by subtracting 4x from both sides. 5x minus 4x is x. leaves me the x minus 15. Here the plus 4x and the minus 4x do each other in. That leaves me with 8. To solve for x, I simply add 15 to both sides. And x is equal to 23. You should always check these. Some of them you can check mentally. For example, if I take 23 and plug it in for x here, 23 minus 3 is 20. 20 divided by 2 is 10, so this becomes 10. If I plug 23 in for x here, 2 times 23 is 46. 46 plus 4 is 50. 50 divided by 5 is 10. So the left side is equal to the right side. So you don't always have to physically check these by actually plugging it in and simplifying both sides. Some of these you can check mentally. You should always check your answers. Last example, solving equations, deals with decimals. We have 0.9x minus 8.1 is equal to 2.43. And if you don't like dealing with decimals, just like you may not like dealing with fractions, you don't have to. You can eliminate the decimals by making all the numbers in this equation a whole number. So what you would do is you'd multiply by the highest power of 10. That will make each one of the individual terms in this particular equation have a coefficient or a constant that is a whole number. So for example, this is 9/10. In order to make 9/10 a whole number, I'd have to move the decimal one place to the right, which is equivalent to multiplying by 10. To make 8.1 a whole number, I have to move the decimal one place to the right, which is equivalent to multiplying by 10. But in order to make 2.43 a whole number, I'd have to move the decimal 2 places to the right, which is equivalent to multiplying by 100. 100 is greater than 10, so that means I need to multiply everybody through by 100. So to eliminate the decimals, multiply by the highest power of 10 that will eliminate all the decimals. So that means I got to multiply both sides by 100. Remember, what you did to one side of the equation, you have to do to the other. Distribute the 100. So that's 100 times 0.9x minus 100 times 8.1 is equal to 2.43 times 100. Now remember, when you multiply by power of 10, you move the decimal to the right the same number of places as you have zeros in your power of 10. Here I have 2 zeros in my power of 10, so I got to move this decimal 2 places to the right, which means I'm going to have to add a 0. So that gives me 90x. Same thing here. I'm multiplying by 100. I have 2 zeros in this power of 10, so I've got to move this decimal 2 places to the right, so I'm going to have to add a 0. So that gives me 810. Here, I'm multiplying by a power of 10. I have 2 zeros in that power of 10, so move the decimal 2 places to the right. So 90x minus 810 equal 243 is equivalent to the original equation that we started with, but this one doesn't involve any decimal numbers. So to solve for x, I need to add 810 to both sides of the equation. Here, the minus 810 to plus 810, they do each other in. 243 plus 810 is 1053. And now we'll divide both sides of the equation by 90. And that will give me x is equal to 11.7 if you do that division. So this is the solution to this particular equation. And again, if you don't like dealing with decimals, you don't have to deal with them. Multiply by the highest power of 10, that will eliminate all of the decimals.